In this video, I'm going to describe process method prototypes for process methods of cognition models. So from the previous video, you may have noticed that, or may have wondered, how is it that a given command is associated with a given process method? So we had our assess routine right here, and it initiated engage, but what that resulted in was this particular process method right here, the cognition engage process method being executed. How was that association between that text name engage made? How did we establish that association? In fact, if we go look at the scenario and we look at our cognition model, so this is our EXM cognition model. We have methods right here, and there's this table, and it shows the command and it shows the method with which the command is associated. So again, how is that association made? Well, that association is made with something that we call a cognition model prototype. And specifically, it's a prototype for each particular process method. And those prototypes are defined in a really friendly graphical application called the Model Prototype Editor. So if you would go to your Flames project and go to within the launcher, and you'll see underneath the applications section, you'll see something called the Model Prototype Editor. Go ahead and double click on that, and you're going to get a window that looks like this. So the bottom of my window is chopped off because of my screen size here, my video size, but this is the Model Prototype Editor. So click the Open tool in the toolbar and navigate over to the folder that contains the source code for our EXM Cognition class, which is in Build, F-Tutorial, F-Cognition. Here's our EXM Cognition, and inside there's an FMPP file. That is the file extension for Flames model prototype files. If this file was written, this class was written in C, it would just be FMP, but almost all of our models are written in C++. That's the preferred language for model development. So I'm going to double click on that, and you'll see here that I've got multiple values listed here. This particular window, if you might notice, it's very similar to the entity editing windows in Forge. So I've got menus across the top, I've got these tools across here, I've got a list of prototypes down the side, and as I click on them, I'm getting different types of prototypes. That's really the class of the prototype, not the class of the model, but the class of the prototype. And even though we're editing an individual file, we have a user interface that's very similar to editing entity meta objects. So this window works the same, except it's not loading the data out of the database, it's loading it out of a file that's associated with this class. So we define a bunch of stuff in this file, and we save it off, and it gets made a part of our solution right here. So here it is, a part of our solution. And there's a custom rule defined for this solution. You can see here it's actually just a bunch of XML information that's in here that defines the prototype. The rule for this solution runs the Model Prototype Editor, that same graphical application, but it runs it in compiler mode. And that prototype editor will actually generate code from the information in this model prototype file. And that code gets compiled just like any other C++ code. And that code then is linked into the DLL. Now, the most important part of that code is a particular function called define prototypes. And you get to specify the name of that function in the C generation or the code generation settings for the model prototype file. So I'm going to click on that, and I get to say what language I'm generating the code in. I have to specify the header file because the code that is being generated references the fields of my class, and it needs to know the definition of the method, so it needs to know the class definition. And then I specify the name of the function that I want. So it's always the name of the class, and by convention, it's called define prototypes. It doesn't have to be that way. You can call it Jack or Jill or Harry, but what we do is we always call it define prototypes just by convention. And then the name of the file that the output that the code is going to get generated to has the exact same beginning, the exact same file name. So it's MP. So it's our class abbreviation followed by the two letters MP. And then the extension is CPP because this is a C++ source code file. So I can generate it interactively from within here if I want to, if I make a change and stuff, but I don't have to. I can just cancel out of this. And when I save it and then I build, it will build that model prototype file. So I have a prototype for each process method. So this is a process method prototype. And here are my 3 process methods. And the name of the prototype is exactly the same name as the process method, except that it doesn't have the 2 little colons in between the name of the class and the name of the method. So this is the way you name the prototype. That's the convention. And so that when it shows up in the window here, it shows up with the name without the colons in it, because that comes from the prototype. So now we're eventually going to talk about a lot of other things in this window, but the first thing I want to tell you is we have to specify the name of our class, and that has to be exactly the same as the name of the class that you use when you registered the class. So over here in the class initialization routine, we specified the name of the class. So the name that you specified there has to be the same as the name of the class right here. And by the way, when you use the model prototype or the Flames component copier to copy a cognition model, it will actually copy the model prototype file as well. And it will change the names of all the process methods to the new name of the class that you specified automatically. It's built into the functionality of the component copier. So you'll not only get all the code copied and renamed, but you'll get the model prototype file copied and renamed. And in fact, it also copies the template file, and it renames all the fields inside the template file as well. So there's another tutorial where we make complete copies of classes to show you how to create a new class, and you'll see how the component copier will copy these files as well. So the next thing we specify is the intended command, and this is the place where the correlation is made, the association is made between the name of the command and the name of the process method. So that's the association that we see in this window right here. So it's the information in the prototype that gives us this information right here. It gives us this association. So that's how you do it. You don't have any code to write. You just have to edit the prototype in this graphical application. So while we're here, we're going to point out just a couple other things about the prototype. One of them is for our command here. So it's a prototype for the command as well as now a prototype for the process method. We get a chance to specify a description of the command. Well, that's the description that shows up in Forge. So I'll go back to Forge, I'll go back to the units window, and I go back to this, and I click on this command, and I see this description right here. That's the description that we see in the model prototype editor. It's exact. So we very much encourage you to make sure you have nice descriptions, so that the intent here is to allow the end user to be able to figure out what a unit is capable of doing by just going to the unit and seeing its available commands and just clicking on the command. So there's that same description right there. You have a good enough description that you can read these commands and say, oh, let's try this and let's try that. So without having to refer to any documentation, the commands are documented. So they're self-documenting, and it just makes a world of difference for the end user. So put a good description here. And the rule or the convention that we have for how we write these descriptions is as follows. We say that this first sentence should start with a verb, should always start with the verb, and it should complete the sentence, I want the unit to. And then you put it out. So it doesn't say illustrates how. It's complete in the sense I want. Well, this is actually a horrible example, come to think of it, because I didn't actually obey this rule here. I want the unit to illustrate how to receive commands, but that's what we do for other commands. So that's how you write the description. Now, there's a bunch of stuff that we're going to talk about here, and we go into more detail of the process method prototype. But what I want to show you, I'm going to skip down here to the input section. So the input section is where you get to specify what inputs you want to be required or optional for the cognition for your process method. So I have specified an input called search range. I've specified that its data type is distance. So I've got a bunch of different data types here that are supported. And then I specify other things about it, and I specify description for the input. And so that's the description that shows up when I click down here. So we're going to spend a lot more time talking about inputs in another video. I don't want this video to get too long. I just want to give you the top level information about a prototype, and we'll get into more details later. So you have the name of the command associated with the name of the process method. You have a description of the command. You identify all the inputs, and then you have a comment that describes each particular input. You define one of those for each of your process methods, and that is one of the things that this prototype allows you to do. So there's a lot of code that gets generated as a result of the information in the screen, and there are a lot of different options, and we're going to talk about most of those options in successive videos. But all I wanted to do at this point was just introduce to you the prototype, so that you can understand how the association is made between commands and process methods. So that concludes this video introducing cognition model and process method prototypes. Thank you for listening, and thank you for using Flames.